So the first couple of definitions here are probably ones that you've already heard. The first one is a right angle. That's an angle whose measure is 90 degrees. And then a right triangle is just a triangle that has a right angle. All right. And so we have a group of Greek philosophers that were quite old. This is like 500 BC. They studied under Pythagoras. And he is actually the first one that's given credit. But if you look at even like Egyptian pyramids, which were way before 500 BC, they used the Pythagorean theorem to square off pyramids. So, I mean, the concept has been used prior to it actually being identified. But it's been identified and labeled Pythagorean theorem because he's been given credit for it. The first thing, the term theorem. A theorem is a statement that has been proved to be true. So you have like a hypothesis. If you think back to like science and you're doing experiments, you have a hypothesis, and sometimes an hypothesis can come to fruition and you prove it, and sometimes they don't. A theorem has been proven to be true. And so a theorem is going to work all the time. You have kind of an if-then statement that's given with it. And if the first part happens, then you can assume the second part will, because the theorem has been proven. So this theorem is the Pythagorean theorem, meaning that it has been proven. It says the sum of the squares of the lengths of the legs of a right triangle is equal to the square of the length of the hypotenuse. And so they've given us a right triangle here. What they're saying is that, and you're going to hear it, a squared plus b squared equals c squared, which is what you see right there. But what they're saying is the legs. The legs are the sides that make up the right angle. Those are the legs. The hypotenuse is always the longest side, and it's always opposite of the right angle. So if you were to stand in the corner of the right angle and walk across the triangle, you would run into the hypotenuse. That's the hypotenuse. The other two are the legs. And so the theorem says that if you take each leg and square it, and you set it equal to the square of the hypotenuse, that will always be true. A squared plus b squared, the leg squared, will always equal the hypotenuse squared. All right? And they typically label it A, B, and C. So C will almost always be the hypotenuse, but you do have to pay attention just in case they didn't use A, B, and C. So let's just see how we calculate this given some information. Look at example 1. This says find the length of the side B in the right triangle ABC. So the first thing we have to pay attention to is what is our hypotenuse? Well, if I look at this one, my hypotenuse is going to be the longest side and the side that is opposite of my right angle. That is my longest side, and it's the one opposite. So that's the hypotenuse. So if I were doing this particular problem, I would say, well, 12 squared plus b squared, which I do not know, should equal 15 squared. All right. So you should know 12 squared. That should be one that you know. 15 squared is actually not bad either. So 144 plus b squared equals 225. So how do I solve that? What's my first step to solve? Subtract. So I'm going to subtract my 144 over. I get b squared equals 81. How do I solve this guy? How do I get rid of a square root? What's going to get rid of what's going to get rid of a square? Just told you. So if I do this, it will get rid of the square. Remember when you take, if I were to look at b squared, right? The square root of b squared is just going to be b, which is what I'm solving for. And so you can really take the square root of both sides and you're going to get. Now, normally when you take a square root, and we haven't done this yet, but normally when you take a square root and you have a variable involved, you have to consider the fact that the positive and negative would work. For example, what is the square root of 81? 9. It is 9. When there's a variable involved, you actually have to also consider negative 9. Why is that? Well, because negative 9 squared is also 81, right? In this case, however, I am talking about right angle trigonometry. I'm talking about a right triangle. I am looking for a length of a side. A length can never be negative 9, right? You can't go into Lowe's and say, hey, I want negative 9 feet of lumber. They're going to look at you like you're crazy because length has to always be positive, right? And so if I'm talking about the length of a side, I don't have to consider the negative. But when you get into later math and you start doing this, you're going to actually consider both of them. For this case, however, the square root of 81 is going to be just that 9. And so because I don't have to worry about the negative, I'm going to say it's going to be positive 9. And I can check it. If I am saying that Pythagorean theorem always works, they told me it's a right triangle, I can say, well, does 9 squared plus 12 squared equal 15 squared? And if it does, then I know I got the right answer, which, by the way, it does. All right, so Pythagorean theorem will always work for right triangles. Tell you right here, when you have an x squared, you're going to take the square root of both sides, and it is going to be the positive or negative root. However, if we're talking about a triangle and you're looking at length, you can exclude the negative piece of that. So I have another problem here. They said, I want you to find now which side am I looking for now? A leg or hypotenuse? The hypotenuse. So I am going to set this up exactly the same. I'm going to say one of my sides squared plus the other side squared is going to equal my hypotenuse squared. All right. These are obviously easy squares as well. 20 squared, right? That's just going to be 400. 10 squared is 100. So that means that 500 is going to equal c squared. So in order to solve this, I'm going to take the square root of both sides. Here's the thing. 500 does not have a perfect root, right? And so with something like 500, I'm going to have to do the process that I've been doing all along in this chapter. I am going to have to go through and figure out what my simplified version of this is, okay? And so when it does not have a perfect root, you want to do your factor tree and simplify it as much as possible. You don't want to leave it like this. That would be like giving me an answer like that. All right, that's not simplified. So if you can simplify the root, you want to, and you're going to do it the way that we've always done it. You're going to say, well, a 2 can come out, a 5 can come out, and then this 5 is going to stay in. So 10 square root of 5 is going to be the length of my hypotenuse. The distance formula that we're actually going to learn in like the next page is based off the Pythagorean theorem, all right? Distance formula, by the way, is something, distance and midpoint are something that you're going to, it's going to haunt you for the rest of your math life throughout high school, right? So you're going to see the distance formula this year. You're going to see it in geometry. You're going to see it in Algebra II. And if you go past that in pre-cal calculus, you're going to use distance formula. Like it is forever here. What's nice is that it's based on the Pythagorean theorem, which is a fairly easy guy, okay? And so if I were to look at this particular problem, clearly I can see what my hypotenuse is, right? Right there, that's easy, okay? And so if I am trying to find the distance between 2 points that are not either on a horizontal or a perpendicular, then I'm going to have to use Pythagorean theorem to figure it out. For example, if I wanted to know how long this line was, I could literally just count my units, right? Because I'm going from -3 to +5. This is clearly 8 units long, right? If I have a vertical line and I'm going from 1 to 4, that's 3 units long. But here's the problem. I have 2 things changing when I go diagonally like this. And so on the coordinate plane, when you are looking at a diagonal line and you want the length of that, then you implement, well, that's Pythagorean theorem, because I can take any diagonal line and I can create a perfect right triangle with it. And so that's what I'm going to do. I need to do my a squared plus b squared. In order to do that, I actually have to subtract numbers, right? And so if I were to take these numbers then, I would say, well, I need to know how far apart this is. We actually just calculated it. In order to figure out how far apart they are, what I did is I calculated my x's, right? I took one of my x's, we'll say 5, and I subtracted my other x, right? And that actually tells me that that is 8 units. And then to do my other leg, I did the same thing, but I did it with my y's. So I said, well, that's going to be 4 minus 1. This length is going to be 3. And so if I want to then figure out the length of the hypotenuse, I'm going to use Pythagorean theorem. I'm going to say, well, 8 squared plus 3 squared should equal the length of this D right here. So if I did this, you could do it the other way. This is technically absolute value because you're talking about distance. So you are going to always subtract, but it actually doesn't matter which order you subtract in because you're actually going to end up squaring. So if I had just done -3 minus 5, I would get -8, and then I would square him, and he's still going to be 64, right? So it doesn't matter which order you subtract in, but you are always going to subtract. So once I do that, I'm literally just solving. So I have 64 plus 9 equals the length of that guy squared. That's going to give me 73. And then I'm going to take my root of both sides. Technically, it's the positive and negative root, but we're talking about distance here. 73 won't simplify, so my answer is the square root of 73. And that's how long it is. So then how does that give us a formula? If you look at the next page, page 459. So then I don't necessarily need a picture to do this if I just have 2 points. What happens is that I'm just going to take my 2 x's. They put generic x's in here, x1, x2. They put generic y's in here, y1, y2, and they just subtracted. It does not matter what order you subtract in because you can notice that it is absolute value. What you're going to do then is you're going to add those. So I'm going to take whatever happens when I subtract that, and I'm going to square it, a squared. And then I'm going to do the same thing with my y's. I'm going to subtract those, and I'm going to square it. And then at the end, I will have solved for this guy squared. So I always solve by taking the square root. This is a squared plus b squared. It equals c squared. So to solve for c, I take the square root. And that's actually my distance formula. My distance formula is you subtract your x's and square it. You add that to subtracting your y's and square it, and you take the square root. It is literally a squared. We're saying c squared equals a squared plus b squared. To solve for c, we take the square root. C is going to equal the square root of a squared plus b squared. We found a and b by subtracting our x's and subtracting our y's. So the distance formula looks very daunting when you just see it, but it's really just based off of the Pythagorean theorem. All right, you subtract your x's, you square it, subtract your y's, square it, add those up, and then take the square root. So you don't necessarily need a picture. Look at example 4. Use the distance formula to find these. They didn't give me a picture. It's okay. We don't need one. So we are going to just plug those into the distance formula. The distance between those 2 points is going to end up being my x's subtracted. It does not matter what order you subtract it in. So if you struggle with negatives, always do the smaller away from the larger, okay? So if you want to say, well, this is going to be 5 minus 2, that's quite all right because you're going to square it. All right? 1 minus 1 is a very nice and easy square. So we have 5 minus 2. If we square that, that gives us 3 squared and 0 squared. 3 squared plus 0 squared is 9. And 9 has a perfect root. What is the distance between those? 3 is my distance. So even if I have positive and negatives, I'm going to subtract. Doesn't matter what order you subtract in, but you do need to pay attention to your rules. -2 minus 6, that was -8. -9 minus a -5, that's -4, right? Pay attention to your positives and negatives so that you add and subtract correctly. But once you square it, you should always get a positive plus a positive, all right? If you end up with a negative in this root, you did something wrong, okay? You should always have a positive in the root when you're doing Pythagorean theorem because it is a square plus a square. A positive plus a positive always. And then once you do that, just make sure you have simplified your root. Use your factor tree. Anything that groups in twos will come out. Anything that doesn't will stay in. So midpoint formula is looking not for the distance of the whole line, but they actually want you to specifically tell me where the middle of that line is. Here's the thing. They give you all these crazy numbers here. If I were to just ask you for the middle between two numbers, what would you do? So if I said, what's the middle between two different numbers? How would you do that? There's another name for it. Like between 2 and 8, what would you do? Yeah, you would just add them and divide by 2. It would be the average of the two numbers, right? So if I took 2 and 10 and I added them up and got 12 and divided by 2, I would get 6. 6 is halfway between 2 and 10, right? So you actually just add the numbers and divide by 2 and you average it. Well, so now I'm not just averaging a horizontal line or just averaging a vertical line. I'm averaging a diagonal line. So I just average the two pieces of it. I average the x's, that's the x value of my midpoint. I average the y's, that's the y value of my midpoint. That's literally all this formula is telling me. So if I look at the actual formula, besides this crazy thing that they give me, you'll notice to find the midpoint, I add my two x values and divide by 2. I add my two y's and divide by 2. Here's the thing. Distance will always be positive. Midpoint is not necessarily. Midpoint is actually giving me the coordinates of a point, which would be positive in the first quadrant, right? Positive, negative. Like it depends on where you are on the graph as to whether it's positive or negative. So you don't assume positive with midpoint. Midpoint is giving me coordinates, and coordinates can be negative. Distance will always be positive. Midpoint depends on what you've been given. You literally add your values up and divide by 2. So let's look at the example here. Find the midpoint of the segment with the endpoints -3, 1 and 5, 4. So if I want to find the midpoint, I am going to take my x values, -3 plus 5. And I'm going to divide by 2. That will be the x value. Then I'm going to take my y values, 1 plus 4. Divide by 2. You want to simplify, they put it in a mixed number. I don't make you do a mixed number. So like -3 plus 5, that is 2 over 2. I'm going to make you simplify that. 1 plus 4 is 5 over 2. The only thing I am going to say that you must do is reduce if possible. So like, don't leave him like that. Make that a 1. You are welcome to leave it as 5 halves, or if you're graphing it, this is the only time that I would say this actually benefits you. It's easier to graph 2.5 than 5 halves. Just mentally, it's easier to find that on the graph. But I will take either one of those answers. You can just reduce your fractions and leave them as improper, or if you are more comfortable doing mixed numbers, you're welcome to change it to a mixed number. But either of those are acceptable answers.